Welcome. Just checking whether we have excellent people coming in. Good morning, or good afternoon, or even good evening, everyone. Keeping a short moment to have all of you coming in. We have about over 200 people registered for today's webinar, which is good. So welcome to the PEFC Building a Circular Economy with Timber webinar. Thank you for joining us today for PEFC hosted webinar. A fascinating topic with 3 ingredients. First, a much needed circular economy. Second, a building industry focused on reducing its carbon footprint. And the third ingredient, timber. Besides, there is another underpinning and enabling ingredient, and you might have guessed which one it is: forest, and more precisely, sustainably managed forest. So this webinar will be conducted in English. We will have a Q&A time for a Q&A session at the end, but I invite you already to, as you hear our speakers and come up with a question, I invite you to type it in the Q&A app that you will see at the bottom ribbon of your Zoom page. All right, so today I welcome 3 experts. Jamila, if we could, I will share from my end. Okay, thank you. So today we welcome 3 experts. I will introduce them in a little bit more details at the beginning of their session, but we welcome Charlie Law, Sustainability Director at Timber Development UK. Morning, Charlie. Morning. Melanie Bourges, Timber Engineer at Stora Enso. Nick Elias, Architect at Architectus, all the way from Australia. So good late evening, Nick. And I'm Fabienne Sinclair, and I will be your moderator for this session, this webinar. Before I hand over to our panel, I would like to take a moment to say a few words, updates about PEFC. And of course, starts where it all starts, in the forest, and recognize forest for what they give us in terms of their ecosystem services, values and benefits, and you see some of them here: biodiversity, water, soil, as well as their social dimension in terms of the community and indigenous people that they host, and workers that are directly or indirectly working on the forest and timber industry. And of course, carbon mitigation. A key element, as forest is the main natural machine for carbon mitigation with storage, sequestration, storage, and substitution. So this is where PEFC comes in. This is where PEFC comes in because overall forest plays a key role, and for that I want to go back to the previous slide. my mouse is being playful. So sustainable forest management plays a key role, and this is where PEFC comes in. PEFC is an NGO dedicated to forest and their values, to the planet and people. You can find our mission and vision on our website, pefc.org. PEFC at .org. And our focus areas are simple. They are dedicated to climate change, to conservation and regeneration. We speak a lot about deforestation at the moment in the context of EUDR. But of course, we are focused on this through conservation and regeneration. We're also focused on smallholders, on biodiversity and traceability, and I'll come back onto that. Okay, today, the program for the endorsement of forest certification, we are an alliance. And you see the result of this alliance here on this map, whereby 45 countries, and we also call them system, are endorsed to PEFC International against our sustainable forest management benchmark. And this makes up 296 million hectares of certified forest, accounting for 76% of total certified forest around the globe. So you see all these dark greens is where forests are certified to PEFC certified standards across a global benchmark with some national specificities. As you can imagine, we don't manage a forest in Germany the same way as we manage one in Brazil nor in Australia. So this collective strength is very important to achieve not only the larger scale of certified area and material, but also to give you access to certified material. And this traceability comes through over 28,400 certified sites in 80 countries, whereby you can find suppliers with PEFC certified audited material that will come into your supply chain. Next slide, please. And in terms of overall view, today, only 11.4% of global forests are certified, so there's still a long way to go. So the more demand for certified material, the more it will enable us to grow this. And 15% of certified forests are dual certified to ourselves, PEFC, and our colleagues, FST. On the right-hand side table chart, you see where we stand. So PEFC with, at the end of September 2024, 296 million hectares, and our colleagues FST at 159 million. And the drop is due to the withdrawal of certification in Russia and Belarus. Next, please. So responsibly sourced from sustainably managed forests comes into two actions, two core steps. And this is an oversimplification, but it's just a way of explaining it. First of all, we have what's happening in the forest. Next, please, with the Sustainable Forest Management Benchmark to enable us with healthy forest ecosystem, in terms of the biodiversity, carbon, healthy workers, and all what encompasses the protection of their right, their safety, and so on and so forth. Healthy communities with the respect of indigenous people's rights, following FPIC concept and implementation. And of course, healthy local economy. So for forests to stay forests, they need to have a value. And this economic pillar is important, as well as the social and environmental pillars. The second step, the second element for all this good work taking place in forests to be benefiting to the supply chain is the chain of custody certification to enable the traceability of products. So it's the assurance of the origin of those products from sustainably certified forest, assurance of legal compliance, and for materials that are not coming from the sustainably managed forest, but from controlled sources, it's all a suite of due diligence requirements still for you to be sure of the material not coming from controversial sources. So all of this is independently audited through third-party auditors, and really ultimately giving you the assurance of traceability. Next, please. And before I hand the floor to Charlie, I would like to already invite you to contribute to strengthening PEFC, and here specifically one key product relevant for the built environment, which is the project certification. Project certification is a part of our chain of custody standard to enable the proof of the certified material that you are using, and ultimately the certified building or part of a building that you have erected. So promote your sustainability efforts, add value to companies, and with that also align with the chain of custody standard. This survey is only short, it's a few questions, between 10 and 15 minutes to complete. Responses are kept confidential, and we have another 10 days or so to have your input. That would be very much appreciated. So here's a QR code, and I will flash it again at the end with our contact numbers. So contact emails. So now I would like to give the floor to Charlie. And first of all, let me say a few words about Charlie, and then you can take control, Charlie. So Charlie has worked in the UK construction sector for over 30 years as a sustainability professional for major UK construction companies, including BAM Construct, Kier, and Lendlease. Charlie is the Managing Director of Sustainable Construction Solutions and Sustainability Director for Timber Development UK, the largest supply chain body for timber over there. And this organization promotes the building for a better world through wood. Charlie, welcome, and the floor is yours.
Thank you very much. Good. Hello, everyone. Yes, so I'm going to be talking about the introducing timber and the circular economy. Thanks, Fabienne, for the introduction. So, what is the circular economy? I think we're fairly au fait with that here today. So, you know, the old linear economy, the take, make, and dispose model is the old model that's really out of date now. And just some figures here for the UK. This is sort of the process that probably happens on most construction sites at the moment. You know, most of those operations in that chain will create some form of waste, and that waste generally ends up in some form of material recovery facility. And you can see there that a significant proportion still goes to landfill, so around 8% in the UK. But the remainder is diverted from landfill, but a lot of that ends up in what we call energy recovery, so making energy, electricity from that waste material. And very little actually comes back in a circular economy process. Timber is maybe a little bit of the exception there in some of that. You know, timber, we've added some more slides. So this is from CEI Bois, which is the European Timber Federation. You'll see that timber is actually quite circular. Trouble is, we still got a lot of that timber ending up in energy recovery. We're not sure what's going back into reuse and refurbishment, but believe that has been dropping over the years because smaller timbers have been used. So the larger timbers that would normally have been used to construct you know, new buildings that might have come out of old buildings are no longer used. So we've still got that big, around 2/3 of the timber that ends up in energy recovery. A fair proportion does end up in things like insulation and animal bedding, but really too much going into that energy recovery. And that's really what we need to change. So the circular model that I like to see, or would like to see going in, is we've got our raw materials. We obviously design out our fossil fuels. We look at our production and look at how we can change that to be more to renewable energy. We then need to look at the business models, and we'll touch on this at the end. Do we need to actually sell our products, or should we be selling our products, or should we be looking at other models? We then have our installation process, and obviously everything from that process should be able to be reused or recycled back into the original product. We then have our product cycle, where it's installed, it's used, it should be maintained, and that maintenance keeps that product in use for as long as possible. We then, when it does get to the end of its life, it's deconstructed and the product itself disassembled into its component parts wherever possible, and they can be reused or refurbished back at the factory, remanufactured, or last resort is then actually recycling into new raw materials. And where those raw materials can't be used within the existing process, there is a defined use elsewhere, and that then reduces our need on raw materials from the forest, and that includes timber. You know, if we're going to build more in timber, we do need to make sure we make the best use of that resource throughout its entire life. So how could we do that within timber and a circular economy? Well, I think there's 5 key areas that we need to look at. We need to design for resource optimization. We need to design for low embodied carbon. We need to design for optimum service life, ease of maintenance, and then flexibility and reuse. So we'll touch on each one of these in turn. So resource optimization can be interpreted in a number of different ways. We can make the best use of the existing resource available on the site. So e.g. use of the existing structure and materials from that existing building wherever possible is what we should be doing first. We then make the best use of the resources from the forest, for example, using something like an OSB board, which uses the fibre from the thinning of the forest, for example, or co-products from the primary processing, such as chipboard. And we can then make the best use of that resources that are brought to site, so things like designing to standard product dimensions to reduce waste. Just an example here, this is the Aleander HQ in the Netherlands, an old industrial complex built in the sort of 60s or 70s, from what I understand, or sorry, early 80s there, some of it. That was transformed by reusing all of those existing buildings into a new HQ building that you can see there, and that is the actual building. That is not an AI image. That is the actual finished product, and all those concrete buildings that you saw in that previous picture are those timber pods that you can see poking out the side of that atrium. So, you know, a very good transformation of an existing building, which means you're lowering that resource. In turn, we're optimizing the resource from the forest. So rather than using things like maybe plywood, which would be using a virgin material, could we be using things like OSB? And these are a couple of examples. You know, Sterling board is a make in the UK, made by Norboard. That could be used for your mattresses or in your your support within partition walls, or sheathing boards and things like Smart Plies. They're what they call their pro passive product, which is good for passive house building. So all you have to do on this particular product is actually take the joints of those boards. You don't need any further airtightness measures, so it's saving time. As far as the low carbon, obviously timber stores carbon for the life of that building, so that timber is sequestering carbon out of the atmosphere while it's growing. So we can then store around, you know, looking at that, it's around a ton of carbon for every ton of timber that's used on the project. So that is a great asset for timber. We can make sure that timber that carbon is stored out in the atmosphere and not emitted as part of the process. Reducing replacement cycles is the next one then, and things like looking at how we could move boards around. So do we use something like a reusable flooring system, or or timber flooring that can stay in place for a number of years, rather than say maybe a carpet floor which might have to be replaced after a short amount of time. When we're looking at facade systems, could we look at additional treatments, maybe something like Accoyas or something like that, where that could extend the life of that particular life cycle from maybe 30 years to more like 60 years, taking out a replacement cycle in between. Similarly with cladding, this is an example. This is a thermally modified product called Brimstone, whereas, you know, softwood cladding, particularly in the UK, which is quite wet, might only last 15 years. But with this type of system, again, that becomes much more durable and could last up to 60 years. So you're replacing, you know, 2 or 3 cycles there from the building life. And obviously, when we do the frame itself, we must make sure that's detailed and constructed correctly to ensure that that frame has a long life, and that very much means moisture control on site and things like that. We could look at things like timber selection, looking at durable species, whether that's softwood such as you know, larches or cedars for cladding, or we could look at you know, hardwoods such as this sweet chestnut here, or even oak, for the external cladding element. So look, timber selection is a good way of making sure, and make sure you look for that durability of that timber to make sure it's going to last where you want to use it. Chemical treatments are obviously used for a lot of timbers within the building. Different use classes, usually in the building, use class 2, or externally use class 3 or even 4 if it's in ground contact. The only issue with treated timbers is there could be possibilities that those the treatments could limit future reuse. There was an issue in the UK where there was a possibility that some of the timber might have been classed as hazardous. We've managed to disprove that with the industry help. But that doesn't mean that those limits couldn't be lowered even further at the moment. And in 20, 30 years' time, when you come to reuse that timber, it may be above those threshold limits for being classed as hazardous. So it's just one to be careful there. As far as chemical modifications, so using things like Kebony, which is a PEFC product, using ferrovial alcohol to in effect pickle the product. And a similar product is Accoya that you may have heard of, which uses in effect vinegar. And so it's acetic acid. So those types of products, again, you modify the timber makeup so it can last longer. The other option is thermal modification. A couple of options here. Brimstone is actually a hardwood modification process, and it takes non-durable hardwood species such as poplar or ash or things like that, and converts that into a thermally modified product. Again, it heats it up to about 200 degrees. And it changes the internal structure of the timber, so it actually can't take on that moisture. And then if there's no moisture there, there's nothing for the fungi and insects to feed on, so it becomes unpalatable to them. And thermal wood is the softwood equivalent. So, you know, things like that, they do have a higher upfront carbon footprint, some of these products. So you do need to work that into the process to make sure it's going to, you know, the replacement cycles elements matches up for those products. Or we could increase the intensity of reuse. So, you know, hoarding systems at the moment we use in the UK and many parts of the world, we put some timber up and cover that in plywood. And at the end of the job, that would get taken down and go in the skip. Similarly, pallets are generally single use, particularly in the UK. It's around 20 million pallets are used in the UK for transporting construction materials each year. And near enough all of those end up in the skip. But what we could do is look at reusable systems. So this is a hoarded system still using plywood, but making sure that that plywood is sealed. This system doesn't use any fixings. It's basically clamps that plywood in place so there's nowhere for the moisture to get in. And if there's nowhere for the moisture can get in, that timber doesn't degrade. So that timber panel there will last many uses on that site and other sites. Similarly, looking at reuse options, Pallet Loop is a new pallet reuse scheme that was launched last year in the UK, currently being used by British Gypsum for all their bag plaster and plasterboard. And this is a reusable system. The pallet goes out to site, doesn't cost the manufacturer any more, but there's a return incentive for the contractor or end user to return that pallet by offering up to £4. So, you know, so options there that means we can those pallets get reused rather than going in the skip. Looking at ease of maintenance, you know, looking at, do we actually need to treat the product? So this is brimstone cladding again that we had earlier on. That's when it goes into place, and after 12 months, even if you don't treat it, because it's quite stable, that's it. It silvers to this grey silver finish at the end. So, you know, things like that we can do so we don't have to actually, especially if you've got this at any sort of height, you don't then need to treat that timber and send someone up there to treat it. And that's, again, saving carbon because you haven't got someone coming out to site, but also gives that natural aesthetic feel of the timber. We need to design for off-site construction, flexibility in deconstruction and disassembly. So looking at things like reusable fixing. So these are a Sherpa example. There's lots of other examples out there. The flooring that we showed you earlier on is a car's flooring system called their 5S, and that can be dismantled and taken apart and then put back down somewhere else, and you can actually sand this floor because it's got a thick veneer on it. It's about 5 or 6 mil, depending on the specification that you get. It can be sanded down another number of times and retreated. So, you know, again, it allows that reuse. There are some things that we have some question marks around. So things like SIP panels, can they actually be designed for reuse? Maybe by using standard dimensions for those, for example, might be the option there, but a little bit more difficult to allow for that reuse. And then cladding systems as well, we need to make sure that we're designing for them to be demounted. So designing for remanufacture and reuse, at the moment, most stuff will go into things like refuse-derived fuel or open loop recycling, but if we can design these options differently, we can definitely push them up the scale to remanufacture at the very least, and well, you know, at best, sorry, and refurbishment and reuse as well. So, you know, and taking it past maybe the recycling side. So looking at those business models that we mentioned earlier on, we need to look at, you know, for me, it's what we call the 5 R's. So we either, we're going to have the product reused, preferably, refurbished, remanufactured, recycled, or use renewable materials such as timber. So that's, to me, is the 5 R's. Where got recycling, we have both closed and open loop recycling. And preferably it's that closed loop that we want to aim for. If at the very worst, it's closed loop recycling. We shouldn't try not to let our timber get into an open loop system if at all possible. So in those types of arrangements, we really need to maintain the ownership, preferably, of that product, even where it's reused. So can that company maintain that ownership, and then in effect have a different model to lease it out? So that could be any one of these options. The one that we're probably most useful to is things like hiring of plants. So there's then no reason why we can't do that on a longer term basis, maybe on a lease basis for timber products. Incentivized return in a similar way to the pallets, for example, or we can have a service life. So especially where the product needs a certain amount of maintenance, could we actually in effect have a service contract that maintains that product over the life? And just to give you an example of how that might work, we've got those products back in their positions there, so short life or long life service, and we look at their maintenance cycle here. So does it need a lot of maintenance or a little bit of maintenance? And within that, we can start to look at where a certain product might fit. So things like flooring, where it needs cleaning and maybe sanding every few years, or doors that need to be adjusted, refitted, then they might be part of a service contract. A cladding system that might last 30 to 60 years, it might be that we could do a long-term lease on that. And you'd only purchase possibly the frame itself, which is you know, hopefully going to last a very long time. So that's a quick introduction to circular economy. So a quick sort of call to action from me, what we should be doing. Ensure, you know, the circular economy is part of your sustainability agenda when you're looking at a design. Make sure you source your timber responsibly. So we've talked about PEFC today. Make sure that you're making sure you're getting your timber from that responsible source. Incorporate circular economy design principles into your designs, and also consider the business models that will aid your circular design. So thank you very much. I'll hand over back over to Fabienne to introduce the next speaker. Thank you very much.
Thank you. Thank you, Charlie. So yes, just before handing over to Melanie, a quick question on so you talked about the 5 design needs and then the 5 raw material source. Out of the 5 raw material source in the modeling, which one are we which ones are we progressing on the most?
Yeah, difficult question. We're you know, at the moment we're probably near the bottom of that list, using, you know, renewable resources and probably open loop recycling is probably the ones that we are we're using most at the moment, but I think we're starting to get into that reuse element. We've got some examples coming up later on of where buildings could be dismantled and reused. It's difficult for timber as far as the remanufacture, possibly in certain cases, but that's not saying it can't be done. So things like possibly glulam beams or CLT structures that could be dismantled and then remanufactured into new elements. But we're not quite there yet. There is some work going on in the UK around cross-laminated secondary timber, so taking old timbers out of Victorian buildings and turning them into things like CLT and glulam. So hence the secondary timber bit. So we are progressing. It's quite slow, but we need to make sure we're designing buildings to be dismantled really first, and that's where that will take off.
Thank you for sure. Thanks, Charlie. Good.
Thank
so I remind the audience, all our guests online, feel free to type in your questions as we go along to our panelists. So now I would like to invite Melanie. So Melanie Bourges is a timber engineer at Stora Enso, specializing in sustainable design and circular construction. With a background in structural engineering, she has extensive experience in the mass wood industry, particularly in large-scale timber building projects in France. Melanie is committed to advancing low-carbon building practices by actively contributing to innovative research projects such as Wood Circles. Wood Circle is a European Union co-funded initiative aimed at developing circular and sustainable solutions for wood construction. With that said, Melanie, welcome. Thank you for being with us, and the floor is yours.
Hello to everyone, and thank you, PEFC, for the invitation to talk about circular design in timber constructions, and I'm really happy to be part of this webinar. It's working. So first, I would like to start with some reminders of some facts and numbers. Buildings use around 30% of resources on a global scale. And by 2060, buildings sector floor area is estimated to double. So the construction industry already uses huge amounts of resources, and the need is growing. Buildings also create huge amounts of waste. It represents 1/3 of all waste generated in the EU. So it's a surprise for no one here. We urgently need to decarbonize and develop our built environments in a very different way, and from today. Okay, but facing these devastating statistics, actually, the good news is that there are paths to investigate system change. We need to push for the transition to sustainable materials and make construction low carbon, renewable, and circular. And as we see today, there are many people interested and committed to work all together and share information and switch for circular building practices. Everyone is responsible to lead the way. Sorry. At Stora Enso, a transformation framework has been launched to drive long-term agendas where we can have the biggest impact: climate change, biodiversity, and circularity. It will drive our product innovation with a goal of 100% regenerative products on solutions by 2050. But on this more general note, today we'll focus more on solutions and strategies and try to understand what circular principles can mean for designers of the built environment. So Charlie already gave a comprehensive definition of the circular economy. I will try to focus on the main circular design strategy and solutions for designers of mass timber building structures. Actually, circular design can mean many things. It has multiple aspects that are most of the times closely interrelated, but there might be also some tension between principles. Note that not all principles are equally applicable or suitable in all situations. It is essential to consider carefully which principle should be adopted for each project's specifics, and this from the very early stages of the project. So one way to approach circular design is to keep these three strategies in mind: design for adaptability, design for disassembly or deconstruction, and design for reuse. Design for adaptability means designing for both present and future uses. Design for disassembly or deconstruction, it represents the methods for components to be disassembled easily and safely. But design for disassembly does not automatically imply reuse. Additional criteria are needed to increase reuse potential, and that's why design for reuse aims for optimal recovery of products or materials without damaging them or the surrounding components. We'll see that DFA will be mainly presented at the building or system level, while for the disassembly or the construction and reuse, we'll focus more on the component or material level. And one last thing, please keep in mind that in the short time given, I will only present simplified versions of these strategies and an overview of the solutions, but that most of all, it must be understood really as a network of interacting factors. Okay, so let's start with design for adaptability. It aims at providing a building that can easily be adapted to changing needs over time. So it may represent needs in terms of use type, demographics, user needs, or due to external factors such as climate change. We'll go through the three main strategies: flexibility or convertibility, expandability, and designing in layers. While flexibility allows for spaces to change, to fit new or multiple purposes, expandability, as you can guess, it supports the addition of new spaces or features. And designing in layers, it allows design considerations specific to each layer, depending on its intended lifespan and reuse. So to design a flexible building, the first thing is to plan for the adapted building system and structural grids. Usually here, a post and beam system will allow for the most flexibility rather than a complete panelized system. The grid also should be as repetitive as possible. It's important to think of the core position and size also to make sure that it reduces the complexity of changing heating and cooling systems in the future maybe, or if the service riser size will need to increase. Considering the future uses, it may be achieved by a specification of higher loading than initially required. And all these strategies have been implemented in a building concept that we developed at Stora Enso, and that you can see on the right side. It's a structure of glulam beams and columns and CLT floors that can be used as an office or a hotel. The structure can adapt to different tenant needs to prolong the service life of the building. The second strategy of adaptability is to design to expand the building. To expand vertically, it's possible either to oversize columns or substructure, or to facilitate future strengthening, really in order to be able to increase the load-bearing capacity of the structure. And if possible, without major disruption to the occupants. It's important in this case also to evaluate the embodied carbon increase associated to the oversizing and comparing it to the difficulty of future strengthening. For expanding more horizontally, the design will need to facilitate the disassembly of walls, of envelope, of partitions. You'll see here different examples of expanded structures and interesting adaptation projects. Designing for adaptability, it also means to design in layers with independent, accessible, and removable layers. It will allow for longer lasting elements, like the structural elements that we are interested in today, to be kept in use, even if those with shorter lifespans require replacing. So from a structural point of view, it's usually necessary to assess the facade and the structure separately, as the elements of the facade have shorter lifespans. It also means avoiding any unnecessary finishes and planning at very early design stage for separation of the elements. But now that we've seen how buildings need to be designed for adaptability, we'll go more on the component level and see what are the principles needed to disassemble and reuse all the different elements. So the main principles of design for disassembly is to design simple, independent, and easily accessible components. These three principles will allow for and support for a safer disassembly, which is, of course, critically important. I won't go too much into details here, but we can mention the importance of exposed connections with enough room around to plan for parallel sequences of disassembly or to reduce the number of elements. But we'll focus here on connections. While reversible connections are really essential for disassembly and reuse, it represents also challenges considering the potential damages to timber elements. Reusing connections after the initial disassembly may also not ensure the same structural performance as originally designed. So in general, glued connections and timber-to-timber joints have quite low potential for disassembly and reuse. For typical fasteners like nails, screws, dowels, it may vary, but it's usually limited. One solution may be to use proprietary connectors that are specifically designed for disassembly. Usually, the only feasible options for reuse of timber elements with typical fasteners is to install new fasteners in new locations, or to stagger fasteners leaving some holes, or designated location and use in unusual use. The second strategy is to use metal-to-metal connectors, where the connector stays actually connected to the initial elements, leaving, for example, the screws fixed to the timber. But now that we are talking about reuse, we'll end up with the three last principles: responsible material sourcing, longevity, and standardization. To plan for reuse of materials, it's even more essential to source responsible certified products with key accreditations and markings, like of course PEFC, to avoid any unnecessary treatments and finishes. Designing for longevity is also very particularly important for timber structures. Durability and protection plans must be included from very early design stages and validated before the construction starts. And standardization of products also is essential with repetitive dimensions. It will allow for easier transportation, safer disassembly, and easier reuse. And finally, it's also essential to record and document information to support disassembly and reuse of components, but we'll come back to that just after. Here it's a very simplified overview of the reuse process now. The first thing at the end of life of a building is to assess the potential damages, to inspect decay and moisture content, assess the strength class also to the elements. There are different possibilities. The element can be suitable for reuse as a whole, directly, or only partially. In this case, it might require some reconditioning, meaning cleaning, metal removal, and resizing. But if the elements are too damaged, they also might not be suitable for direct reuse. The products then need to be remanufactured, meaning that they will be splitted into lamellas to be transformed in new engineered wood products, like CLT panels or glue beams. And one key challenge here is currently the recertification of all the reused or remanufactured products. And there are many researches ongoing on this topic. I now want also to emphasize the importance for data and documentation at all stages of the life cycle of the building and available to all parties. I've added here only a few examples of data types that support circular processes, like BIM for layer design phases, material passports that are giving useful information, for example, from manufacturers, but also on sites. Disassembly manuals with clear drawings and instructions to explain how to disassemble the elements on site. And we can also mention digital twins that are data models of existing buildings that are regularly updated with record of analytics, conditions, and maintenance throughout the whole building life. Okay, so now we've seen the main strategies to design circular timber buildings. I'll finish by showing some examples of building projects that successfully included these principles. The first one is a pavilion that has been designed for Nordic World Ski Championships using CLT panels that have been disassembled. All the panels have been reused to build a family home and sports centers. For lesson learned, first, the standardization is essential. Here, CLT panels have been reused for walls, and each panel has been maintained in its production dimensions, and drillings and inserts have been kept to a minimum so that they could be fully demontable and reused. And approximately 30% of additional design time has been also needed to plan for reuse.
Melanie, 1 minute, please.
Okay.
Thanks.
The second project is a temporary modular school in France. It has been designed for disassembly and reuse with a target of 85% of reuse. And yeah, modularity is one of the strategies often mentioned for reusability. I will conclude by presenting 2 research projects to show that circularity of timber buildings is a topic which is particularly dynamic at the moment. The first one is a Tumberlook project in Austria that is evaluating the wood waste availability and market potential for reclaimed wood. And the second project is a Wood Circles project. It's a project in which I'm personally involved in. It's a European Horizon project of 4 years, gathering around 20 partners around Europe. Many challenges are assessed. It aims at turning wood waste into advanced building products, developing value chains and digital tools, and it will also participate to the design of a circular reuse by developing a wood-based building system optimized for disassembly and reuse future. It's a super interesting project, and I'm really happy to be part of it. And that's it for me. So I hope this short presentation has given you the overview of strategies to include in your next building projects to design for adaptability, disassembly, and reuse. Thank you. And give it back to Fabio.
Yes, thank you, Melanie. Quite a few things to pick up, but I will come back to this after. One thing that did strike me, though, you mentioned a network of interactive factors, very much like this, and I guess, well, we can come back to it after, but I would imagine it's not just interactive factors, but also interactive actors in the how everyone is collectively progressing this. Thank you, Melanie. So now I would like to invite and turn to our last speaker, Nick Elias. Nicholas is a senior associate at Sydney-based firm Architectus, where he's also a practice design leader. He has many award-winning projects and has an especially strong understanding of public and educational architecture. Nick has won several national and international architecture awards, including from the Australian Institute of Architects, the Premier's Award, and the prestigious Chicago Atheneum Museum of Architecture and Design. Across all his work, he combines passion, strong technical expertise, and a commitment to socially and environmentally responsible design. Nick, the floor is yours. Share your passion, please.
Hi, everybody. Can everyone see me okay in the slides? Okay. I'm really grateful that I was invited to this to share a really sweet and beautiful project. I was the design and project architect on, and I did this for Architectus in Sydney. The building is called the Incubator. It's sited in Macquarie University, so it's about 30 kilometres west of the Sydney CBD. So the CBD is close to the ocean, and it's about 30 kilometres west of that. And so this campus is not a traditional metropolitan campus that has sort of sandstone buildings in the style of kind of a Cambridge or Oxford. This is a more modern campus, mostly characterised by post-World War II concrete buildings. And these buildings are very interesting. They're sort of, I guess, in the brutalist idiom, you could say. And so we've taken a lot of inspiration from that. But really what I wanted to talk today about is this idea that that we've been looking at, and really it's about the idea of the tectonic. So there's an architectural background that there's the architecture that celebrates the relationship of engineering and architecture. Maybe go to the next slide. Architecture can have very different identities, from Frank Gehry's iconoclastic approach, which is shape and form, to Peter Zumpfer and Renzo Piano and so forth, that focus on the materiality and the tectonic. And this first idea is inherent in this project, which is the idea of the tectonic. Now, the word tecton is Greek in nature, and it signifies builder or carpenter. But fast forward to the present, in architecture, it has become, in Adolphe Bourbon in his 1982 philosophical study, tectonic becomes the art of joinings. Art here is to be understood as technique, and therefore indicates tectonic as assemblage, not only of building parts, but also of objects. In Karl Botticher's 1852 book, The Tectonic of the Hellenes, and you can see that middle image, sorry, it's very small on my screen, Boucher interprets the term tectonic signifying a complete system binding all the parts of the Greek temple into a single whole. Maybe go to the next slide. And that's sort of describing that. The second idea is materiality. Maybe the next slide. Or maybe go back to the previous slide. Thank you. Without going into arduous detail, I will quote the German philosopher from the early 20th century, Martin Heidegger, from his 1956 essay on the origin of the work of art. Heidegger believes architecture has the capacity to not only express materiality, but to reveal the different instances and modes by which the world comes into being. Or in layman's terms, to create an architecture that is more humanistic, more of the place it is created for, and I'll quote him now. In fabricating equipment, e.g. an axe stone is used and used up, it disappears into usefulness. By contrast, the temple is setting up a world. It does not cause the material to disappear, but rather causes it to come forth for the very first time and to come into the open of the work's world. The rock comes to bear and rest, and so first becomes rock. Metals come to glitter and shimmer, colours to glow, tones to sing, the word to speak. All this comes forth as the work sets itself back into the massiveness and heaviness of stone, into the firmness and pliancy of wood, into the hardness and lustre of metal, into the lightening and darkening of colour, and so forth. Next slide. These two ideas of the tectonic and materiality are the conceptual ideas behind the incubator. Why these ideas? Next slide. Well, the context of the Macquarie University is a beautiful wooded campus. It's set amongst Australian bushland, and so why not attempt to draw inspiration from context? The other reason, it is an educational setting, bringing humanistic values to the architectural language through the material of wood, which making the spaces inviting to learn and socialise. Now, you can see in this image on the left, sorry, it's a description. He's a Frederick McCubbin is an Australian artist, and there was a group of artists, the Heidelberg School, that were started to understand Australian life, and the Australian, I guess, natural environment without the European overlay. And so it was about establishing Australia as having its own identity. And within architecture, we have always struggled to I guess, conceptualize and contextualize our work in this setting, which is very different from a European setting. We have very harsh sunlight, and so shade, and we have very sort of hot, and it can be hot and dry, and it can be also cold. So we have a lot of extremities. So it's I guess the mid-range, we never really utilize the mid-range, and our shadows are sort of deep and dark. When Utzon first arrived in Sydney Harbour, the first thing he commented on was he'd never seen shadows so dark. Keep going, sorry. Next slide. And you can see on the right, there's an image by the Australian photographer Max Dupain. I encourage everyone to look him up. He's a fabulous photographer, and he did a lot of photography for the Australian architect Harry Seiler and Glenn Murcutt and so forth. But he also did beautiful, iconic photographs, and you can see he's capturing the deep shadows. And on the left is the portal frames within the incubator, and again, it's this sort of celebration of the tectonic. It's the celebration of the materiality, the cadence that comes with the rhythm of structure, and the different tones that can emanate from the building. Next slide. And so the design is simple: 2 pavilions with long span structures, so the client can have the flexibility within the building for the future. The buildings were intentionally arranged to retain as much existing vegetation and trees around the site, and to gently cascade down the side. This approach is derived from both Europeans like Mies van der Rohe, but also from the First Nations, where they built shelters, and they found spaces which didn't require a large amount of intervention, that really could work autonomously in the environment, and, to quote Glenn Murcutt, to touch the earth lightly. But really, there's a pragmatic overlay to all this. The pavilion sizes are determined primarily on the length of what you can fit on the back of a truck, a very large truck, and a truck that's driven at midnight. So the design is determined by transportation requirements, standardised dimensions of timbers, and engineering efficiencies. And I won't bore you with the many and numerous dimensional sizes. These engineering efficiencies are what informs the aesthetics of the building. The long span LVL beams are shaped in such a way as to be structurally efficient as possible. The perimeter V columns are V shapes, as that is the most efficient way, next slide, of holding up the structure. Next slide, please. Reducing the amount of timber used. The facade was also created so it can be totally constructed off-site, and then it was transported to site. The whole facade was standardised. So in this image, we return to the idea of the tectonic, that being the celebration of the part and the whole. In the incubator, it was fundamental to the practical success of the project. The joint system was clearly considered. When a large span beam lands on multiple columns by a 50-ton crane, the joint needs, or the meeting of the elements, need to be super accurate. Therefore, the language of tolerances is crucial, and why every joint is expressed. Timber moves, bends. Next photo, please. bends and so forth, and we'll continue to do so. The joint's aesthetic is its expression of function. This is when architecture and engineering and building visibly meet. And I'll just roll you through the erection of the building. So part of the building, part of our brief was that the whole building could be disassembled and assembled and disassembled. So every element of the project. So you start out with the site preparation. Next slide. And then screw piles. So there is no wet trades on the site. No concrete was employed. All of it is steel screw piles. And then then on top of that, there's a series of timber floor cassettes that float on top of the screw piles. Next slide. And then the prototyping of the facade elements, and then ultimately the facade is locked in. And I heard someone mentioning the Accoya, so you employed Accoya timber windows, and so that they've held up great 8 years later. And also the actual facade is protected by a very deep awning, which is about 3 meters beyond the facade. Next slide. And then the installation of Victorian iron ash columns comes in, and there's a beautiful story. We sourced these iron ash columns, or the timber, from the reforestation of the 1966 fires they had in Victoria, which essentially eliminated a humongous amount of bushland. Next. And then ultimately the cassettes of the ceiling and the roof come together, and they're in these large sort of trays, and they come in and then they lock onto the V columns in segments.
2 minutes, please, Nick.
And then how long?
2 minutes.
2
please.
hours.
2 minutes. Thank you.
As you can see, here's some photographs of it in construction. It was a very kind of beautiful and poetic kind of process, really, and especially I love timber and steel as much, but it's really quite beautiful seeing a building kind of being kind of beautiful all the way through. Next. And these are some drawings done. You can see that kind of, we're trying to speak to the language of the woodlands, and so I'm not sure people understand how Australian hardwood grows, but essentially it creates umbrella type shade structures. And so these V columns really kind of echo that geometry, and you can move through these drawings. And it's all about learning in the open air, so on the edge, and that's really kind of the Australian idiom, inside, outside living. Next. And some final photographs. Thank you.
Fantastic poetry. Thank you, Nick. And learning in the open air, that's definitely where we best learn, I think, anyway. So thank you very much to Charlie, Melanie, and Nick. Now we're going to move into our Q&A session. So there are a few questions already dropped into the Q&A. Thank you very much. Yes, you can all come back to these sections. So I guess, yeah, first of all, yes, we will share the recording of this webinar and the slides and some key takeaways that we will produce. Bear with us, we'll be back with those documents in the next few days. I will take the first one, I guess, around forest certification in Africa. So from a PEFC perspective, we are currently in Cameroon, Ghana, Gabon, and South Africa. Those are Cameroon, Congo, Gabon, and South Africa, beg your pardon. Those are the four African countries where we have either a regional sustainable forest management standard or national as well, and where we are contributing to the education of forest owners and the supply chain as a whole for sustainable forest management and traceability. It's not easy. So again, as usual, we need multiple actors to come together. And for sure, we want to contribute to the development of society and the local economy. So thank you, Elisha, for your question. And definitely timber building is very much appropriate over there as well. We've seen here today examples of probably more premium buildings, but we also need to build in timber in other ways in developing areas. So next question. Thank you, Daniel. Quite of a comprehensive question. I'm not expert, so I will ask Melanie potentially to have a go at it. But I would say, simply put, everything needs to come together. I guess, given the task at hand, it's very much a collective effort that needs to be achieved for this. And I'm not aware of all the standards. Melanie, do you have something to help with this answer, please?
Yes, regarding the normative framework, it's really hard to answer at the moment, as there's currently no really framework organized for reclaimed materials, at least for the structural parts. I know that there are some ongoing developments at the European level to try to assess these questions. I think it will also really be linked to how the value chain will be organized and who will take back the reclaimed materials and reprocess them. So how to say at the moment, I think that we will need a very comprehensive standard framework in the end to really be able to easily reprocess and reuse the reclaimed elements. And also something really important is that all the value chains will need to be actively involved, especially the producers, in order to really work and develop these standards and normative documents.
Thank you, Melanie. So still some steps to go through for these frameworks. All right. We have another question from wait, it's not disappeared. Yeah, it's gone into Répondu. We have another question from Ali. Maybe Charlie, you can take that. Explaining the feasibility of applying a circular economy for old construction that have been treated by CCA and other hazardous chemicals. Charlie.
Yeah, so we've had a big project here in the UK, which just came to a conclusion just before Christmas, actually, where we were testing a lot of old CCA treated timber from around the 1950s up to around 2007, depending on the type of product. And obviously the chemicals used are hazardous, so it was a possibility that the timber, depending on the concentrations of CCA used, could be hazardous. But like I say, we've been testing a lot of timber samples over the last 7 or 8 years, actually. And actually, the Environment Agency in the UK is now happy that the majority of those timbers, or near enough all of those timbers, actually are non-hazardous. The only question was on maybe some of the smaller timbers that have got a smaller cross-sectional area, so obviously then a higher concentration of treatment over the cross-sectional area. But so things like tiling battens may end up being classed as hazardous if you test them. But anything really over like 75 by 50 that was treated, so something you'd use in a stud partition possibly, but obviously anything you use in a timber frame, all of those timbers of that type of size were in effect are now classed as non-hazardous in the UK. So in effect, no restrictions to reusing those timbers anywhere really. even if they were classed as hazardous, there are still options because they can still be reused. The only restriction is they can't, in the UK, this is, and it might be different in different areas, but they wouldn't be able to be used in a domestic environment. So, for example, you couldn't use them in a new house. You do need to be able to use them maybe in a new commercial building or something along those lines, if they were classed as hazardous. But let's say most of the timber, the only bits that were still classed as requiring testing and not classed as non-hazardous by default were timber coming out of industrial installations, for example, which may have had other chemicals associated with that industrial processes, and timbers treated with things like creosote, so things like telegraph poles or railway sleepers. But yeah, but other than those products, everything else, so anything used in a building generally can be reused with no issues at all.
All right, thank you, Charlie. I will answer the question about a fair concern about carbon footprint with shipping construction material. This is definitely to be mindful of, absolutely. From a PEFC perspective, as I mentioned at the beginning, we have the largest scale of certified materials, so you can source PEFC certified timber from 45 endorsed system members. And I would say local is best if possible, but then the bigger picture is also considering still the lower carbon footprint of timber versus other material, and really the partnership that you can, and with that the hybrid construction, and also the partnership that you can build with your supplier to potentially offset some of this footprint when shipping from afar is the only solution. Nick, I just would like to go to Nick, please, Charlie, and then I will probably need to close because we're coming to time. Nick, from your perspective and looking at your clients, whether those are public or private clients, how do you see do you see what is their evolution in mindset towards sustainability requirements that they may ask you? Any trends in that sense?
Yeah, there's certainly trends. I mean, the aspiration at the commencement of a project is always that they want, they want it to be sustainable, regenerative. They want everything. They want the Rolls Royce, or as we say in here. But ultimately, the issue is they want the wine on a beer budget or the champagne on a beer budget, and so money. If its form follows finance, it's always comes down to money. And inevitably, a timber building, Architectus and myself have done many timber buildings. And some clients with deeper pockets, say the private schools or some tertiary institutions, they're happy to pay a premium for that. Unfortunately, when you do a larger rollout for, say, the public school system or the more utility-based buildings that actually have much larger footprints, you have to move back towards steel and concrete. And the other unfortunate piece of the puzzle is the compliance landscape. And so the compliance landscape a few years ago had not quite caught up with timber, so there was a little bit of a gap. And so some of the images that you see now would be very difficult, if not impossible, to achieve I can't speak of anywhere else, but I can only speak of Australia and New South Wales. And so in terms of fire, access, egress, all these waterproofing and so forth. So it's extremely difficult, and it's all doable, but it all comes down to money. And right now, economically, it's challenging.
Yeah, understood in this context, bigger picture. But it's still good and actually vital for the planet to maintain this journey towards sustainable building.
It is, and it is vital, but it's also vital that we stay pragmatic about it and we do it. We make achievable steps, because you get very little gain by trying to do big leaps, and you'll get lots of people offside.
For sure. So thank you, Nick. I'll take one last question and then I'll wrap up. In terms of how can recycled wood-based material and reused component be included in a PEFC chain of custody? So yes, this material can be included in a PEFC chain of custody. There are some definition in our standard for the requirement for those material to be considered as recycled material and can feed into the overall volume of your material. So if you drop your email, we can specifically answer this question. So there is from the certified, the recycled mill onwards. This is where the traceability starts from a recycled material perspective. So from a recycled mill onwards. For the inclusion of this recycled material into the PEFC chain of custody. All right, so maybe if we can put the last slide back on, and I would like to really thanks everyone. I think circularity is key. Here we are talking about using it or making the inroads into the construction sector, which is vital. And as Nick said, we also need to stay pragmatic on the other context. But coming back to a sentence that caught to my attention that Melanie said, a network of interactive factors. And I would add, yes, a network of interactive actors, because once again, it's very much a collective effort. It sounds redundant to say that, but that's how we can move forward on all these elements. So here again, if you haven't seen it at the beginning, you can flash this your phone, your camera in front of this QR code to participate into the survey. And I would also like to add one last comment. PEFC is ready for EUDR to help you with your EUDR compliance. And so again, if you would like to know more about this, you can contact us on eudr@pefc.org or visit our website pefc.org, and there's also an EUDR page there. So thank you very much. If we can put the last slide for our contact emails, again, if you would like to contact Hilary or myself on this subject. Thank you very much to our speakers, Charlie, Melanie, Nick, for your insights and sharing some of your case studies and experience. That's very much appreciated. And thank you to everyone online for attending. And I wish you a good rest of the day. Take care. Goodbye.